One rainy Saturday morning, Adam woke up to hear his mom complaining about the house being dirty. "Mom is always grouchy when it rains," Adam's brother said to him. So Adam decided to figure out if the statement was actually true. For the next year, he charted every time it rained and every time his mom was grouchy. What he found was very interesting. Rainy days and his mom being grouchy were entirely independent events. Some of his data are shown in the table below. Fill in the missing values from the frequency table. And let's see, we have this raining days, not raining days, and the total days that he kept data for. And then he tabulated on, or say, the raining day, whether his mom was grouchy or not grouchy, and on a not raining day, whether his mom was grouchy or not grouchy. And there was a total of 35 days it rained, 330 days that it didn't rain, and then 73 times his mom was grouchy, and 292 times his mom was not grouchy. So the first thing that we said, well, how do we figure this out? We have these four boxes here. It's not clear that we can we have enough information to fill it out just with this table. But we have to remember what they told us. They told us that his mom being grouchy and it raining were entirely independent events. Another way of saying that is the probability of his, let me do this in a color that you're more likely to see. Another way of saying that, so independent events, that means that the probability, my pen is acting up a little bit, probability that mom is grouchy. So let me write that. Mom is grouchy. Given it is raining, it shouldn't really matter whether it's raining. It should just be the same thing as the probability of mom being grouchy in general. Grouchy in general. So what does that tell us? Well, we can figure out the probability that mom is grouchy in general. She's grouchy 73 out of 365 days. So the probability that mom is grouchy in general is going to be 75 or 73 divided by 365. It's 365. And so, or at least just based on the data we have, that's the best estimate that mom is grouchy. Of the probability that mom is grouchy. It's the percentage of days that she's been grouchy. So that is 0.2. So based on the data, the best estimate of the probability of mom being grouchy is 0.2 or 20%. And so we should have the probability of mom being grouchy, given that it's raining, should be 20% as well. So this number, so given that it's raining, we should also have 20% of the time mom is grouchy, because these are independent events. It shouldn't matter whether it's raining or not. This should be 20%. She should be 20%. She should be grouchy 20% of the time that it's raining, and she should be grouchy 20% of the time that it's not raining. That what would be consistent with the data saying that these were entirely independent events. So what is 20% of 35? Well, 20% is 1/5. 1/5 of 35 is 7. And once again, all I did is I said 20% of 35 is 7. And if that's 7, then 35 minus 7, that's going to be 28 right over there. And then if this is 7, then 73 minus 7 is going to be 66. And 330, I guess there's a couple of ways we could do it. We could just take 292 minus 28 is going to be, let's see, 292 minus 8 would be 284 minus another 20, 264. 264. Do the numbers all add up? Yeah, 66 plus 264 is 330. So the key realization here is what he's saying he found was very interesting. Rainy days and his mom being grouchy were entirely independent events. That means that the probability of his mom being grouchy shouldn't matter whether it's raining or not. It should be the same probability of whether it's raining or not. And our best estimate of the probability of his mom being grouchy is on the total days is 20%. And so if the data is backing up that it's independent events, then the best way to fill this out would be the probability of his mom being grouchy on a rainy day or a not rainy day should be the same. And that's what we filled out right over here.